R over Y.
It's the reciprocal of sine. Okay, so college algebra. Rational functions. And you had to graph y equals 1 over x minus 3. What do you know happens?
Ask that whole thing one more time. Sorry.
Rational function,
Yeah.
so it's a fraction. What's going to happen in the graph? A specific feature is going to be in the graph.
It's a mirror.
It's not going to have a point at 3.
I have a problem with 3, correct? Can't plug in 3. I get an undefined value. Okay, what happens at 3? We have an asymptote. And then it's, you know, okay, so you graph those. That's where we're going to utilize that knowledge to be able to graph cosecant. So with both cosecant and secant, we're going to, I think it's easiest to think about the reciprocal function. So let's just graph y equals sine x. Okay, so does sine start on the axis or start at the origin?
Origin.
Origin, period length is
2 pi.
2 pi. We're going to go up to 1. We're going to go down to -1. By halfway, we finish the up bump. The second half of the graph does the down bump. And if we go back and forward, we have that. Okay, so that is sine x. Okay, so when x is 0 is where we're going to have problems. Okay, so when x is, not when x is 0, excuse me, take that back. When the sine of x is 0, then we're going to have our asymptotes. So, sine is 0 right here. Sine is 0 here. Sine is 0 here. Okay. Now, here the sine of, I guess this is pi over 2. It's 1. Okay, what's 1 over 1? 1. Okay, these are fractions. Like, at some point, it's going to be 1/2. What happens when I have 1 over 1/2?
2.
I get 2. So for this x value, the sign is 1/2, but when I do 1 over 1/2, I get 2. And we're going to, the same thing, all these fractions, there is going to be 1/10, it's going to be up here. Somewhere here, there's a value of 1/10, and it's going to go there. And so the whole idea of asymptotes is that the graph is going to approach them, never cross them. Okay, so I have this U-shaped. It's not a parabola. It's not parabolic. That is a polynomial function. This is just this cosecant curve. All right. So now, if we think about -1. Sine is -1, 1 over -1 is -1. And now all these fractions, when I put 1 over a fraction, some small fraction between 0 and 1, they end up getting larger. So this curve is just going to be a sequence of just U-shaped curves. And that's it. Okay, we're going to be careful about the period of cosecant. What's the period of cosecant?
Just pi.
Is it just pi?
No,
It's 2 pi. So I need a complete cycle. Okay, and once it starts repeating at the same level. So be careful about thinking that the period of cosecant is pi. Okay, so our full period length is 2 pi. Okay. Amplitude, we don't actually talk about amplitude with respect to secant and cosecant curves, so we don't have to worry about that. But if we had a period adjustment, it's going to occur in the same place. So for example, if we were going to graph y equals cosecant of 2 pi, no, not 2 pi, good. 2x, blue. We're going to say to ourselves the same exact thing that we said with sine and cosine. This has a period of 2 pi, but I'm going to divide by the coefficient of 2, so now my period length is pi. Okay. And honestly, I don't really know how much I think about that right now, because what I'm going to suggest that you do is you first graph the reciprocal function. So since this is cosecant, we're going to talk about sine again. Y equals sine of 2x, which is what you just took your test on. And at this point, then I'm going to think about, oh, my period length is pi. So, oh, here, let's draw a nice black. I don't want you comparing colors. I already wrote this in red, so let's just do sine in red. Okay, so we're going to graph the sine of 2x. Okay, so here, period is 2 pi divided by 2 pi, just like we did before, pi. So that is going to complete our full sine curve. So halfway, we need to get our quarter marks. So we're going to be here, up to 1, down to 1. We're going to cross our axis. Oh, I should have done a negative. Oh well. And be careful. I'm not done. That's not my graph. What do I have to do now?
Label it.
Label it. We could.
I have to do the
Be
cosine.
specific about labeling it. What do you mean label it? Relabel the x-axis.
I would do that,
You
yeah.
cannot. You would.
Don't you have to do the cosine?
Cosecant.
Cosecant.
Which means I probably should do what? Asymptotes. Okay? We're going to draw a reciprocal function. Step 2 is get your asymptotes in order. Whoops, I probably should have wrote a sketch. So we've got an asymptote here, and so now I don't have to. Please do not, if you are a person who loves to memorize, this is going to bite you in the butt. Okay, so if you read your textbook in section 2.5, is this, no, excuse me, 2.6, is this wonderful green or blue box. Let's see, is that secant, is that cosecant? Oh, here we go, here's cosecant. Green or blue blocks that tells all this information, and it's got what the range is, the period, the symmetry, the intercepts, the vertical asymptotes occur in multiples of pi, blah, blah, blah. Okay, I don't want to memorize that my asymptotes are at multiples of pi. I want to say I'm just going to draw my curve, and I'm going to see where does that curve hit the x-axis, because that's where the reciprocal function will have issues, and I'm going to draw those asymptotes. I should have drawn them in blue because those are actually needed for the cosecant graph. Here, this looks totally, it's like totally patriotic going on here. Okay, so we're going to draw our asymptotes, and then we're just going to draw our curve. Okay, and again, this is 1, so 1 over 1 is 1. Skinnier, down, up, and if we do that, whoops, this is pretty poor. All right, does anybody want to go crazy and create a function for us to graph? Yeah,
Negative
Laura?
3.
What?
3/4 secant.
No, not, okay, sure, let's go secant.
Minus 5x.
I'll put the negative there. I'm not gonna give you a function that's gonna have a negative on the inside here.
What about a pi?
A pi? Sure, let's not get that crazy.
There are a bunch of those in homework stuff.
A bunch?
Yeah.
Not that hard. 2.
No, that was one.
More than 2? I don't know, I didn't count. Okay. Wow! Okay. What are we going to graph first?
Cosine?
Cosine. And we're going to graph everything. Y equals negative 3/4 cosine 5x. Okay? So 3/4 is
Amplitude.
amplitude. The negative is going to make my curve do what? What kind of is a negative cosine curve? Starts on the
Negative.
axis, goes up and comes down. And my 5 is going to contribute to our period length. So our period is going to be, I don't know, how do I figure this out?
2 pi divided by 5.
2 pi divided by 5. All right, don't freak out. 2 pi divided by 5. We're going to put that right here. 2 pi divided by 5. We can label this, well, if that's 2/5 pi, then halfway is 1/5 pi. Pi over 5. I mean, and technically you can probably say, well, what's half of a fifth? 10. So this is pi over 10. So if you really want to label your axis, you can. I know a lot of times I do, but for some reason I just bypass it over there. And then if this is 1/10 and 2/10, then this must be 3/10. And then 4/10, it totally works because 4/10 is 2 pi over 5. Okay. My amplitude is going right through my labeling. Oh well. Okay, so amplitude 3/4. 3/4, negative 3/4. Where do I start for cosine?
Negative
For
3/4.
cosine? Totally. Negative. Where am I going to be by halfway?
5/10.
1/5.
1/5.
5/5.
And where am I going to be? Where am I going to put my point? Up. So by halfway, I'm going to go from the bottom all the way to the top.
I had that halfway through.
So I'm going to be there. The second half of the curve, I'm going to finish the down part. So by the period length, I'm just going to end up at the same positioning that I started out with. And then halfway through is where we're going to pass through the axis. A lot of times people struggle with where am I maxing out, where am I passing through. And if you just kind of keep in mind, sine is easier because it's a bump and a bump, but cosine is the upswing and then the downswing, depending on whether it's positive or negative curve. All right, so, and then we can then just say, well, this far is my kind of unit along my axis. I don't really necessarily care about labeling those anymore. So every unit of this length, we're going to do something. So I'm bottom, so now I'm going to cross. The next unit, I'm going to be up. Next unit, I'm going to be down. Or excuse me, crossing. Okay, and then here we'll just cross there. All right, so I got my cosine. Now what are we going to do? Asymptote, so we're going to say what?
Where it crosses the axis.
My asymptotes are going to happen wherever this graph hits the x-axis and is 0, so right through here. Do not memorize whatever that book says. I mean, you can if you want to. You totally could. But I don't recommend it. Okay, now. This 3/4 is kind of, I don't want to call it amplitude. amplitude, but like, this is gonna be the smallest value that the secant curve is gonna reach. Everything's gonna be bigger, okay? So we're not actually going to, okay, I used a lot of reciprocal, flip it over kind of stuff over here. But what's gonna happen, and the really cool thing about these graphs, even when I have a coefficient in front, is once we graph the related sine or cosine curve, the secant or cosecant or secant curve is actually always going to kind of connect or intersect with the other one. It's reciprocal at that point. So I don't have to worry about trying to think about 3/4 is reciprocal and is it 4/3. We're just going to put our point right here, and we're going to draw, since this is the positive portion of the graph, when I do the reciprocal, I'm just going to be the positive portion and the negative portion. This is easy.
So I thought you said that like -3/4 is the lowest that your graph is going to go.
With respect to
With respect to cosine.
with respect to cosine.
But now we're gonna
With
secant.
respect to the original function secant,
Then it doesn't matter.
no.
Gotcha.
If you want to consider the half graph, -3/4 would be the highest of the, and I don't even want to say negative values, because when we shift this in the next section, it might not necessarily be negative anymore. But if you kind of put the x-axis as the middle of the graph, so that -3/4 will be the highest that this portion goes, and +3/4 will be the lowest that portion goes. All right. That was pretty crazy. Was it easy? Okay, I totally recommend graphing the reciprocal function, using it to locate your asymptotes, and then they will always intersect. So this portion of secant will bottom out where cosine maxes out. Okay. Should we do another practice one, or are you ready to move on to tangent, cotangent? Tangent? All right. All right. I don't have sine or cosine to help with this. Will tangent have asymptotes? Why?
Because I guessed it.
It's y/x. And occasionally tangent is undefined. Okay? And if we think about it, this is, if we consider our triangle, okay, when will I have no width of a triangle?
Quad-
So if this is
quadrangular?
0, huh?
No, never mind.
If I have no width, I'm really at pi, and I'm really at 3π/2. Or, if you don't like, the other way to think about it is your pick-a-point method. When will y have a value and x be 0? So the point 1, 0, right there, we don't want to consider that the asymptote. Again, we're thinking of the rotation angle. So that angle, when y is 0 and x is 1, is π/2. This angle, I could be negative and still end up -1/0 is still 0. So then I'm going to rotate and just keep rotating, or backwards rotating. So what's going on? We're going to have an asymptote at π/2. The bottom part of the y-axis, 3π/2. That's pi, 3π/2. This is 2 pi. If I went all the way around and up there, I'm at 5π/2. Again, the book is going to say odd multiples of π/2. We're not going to think about that. If we went backwards, this 3π/2, that bottom y part of the y-axis, that angle is still going to be an asymptote for tangent, which means now at -π/2, a negative rotation angle, we have an asymptote. If I went all the way to the top part of the y-axis in a negative rotation, I would be at negative 3 pi over 2. Okay, all right, now, you are not going to necessarily have to use this thought process all the time, but this is the first time we're graphing tangent, okay? Let's think of the other quadrantal angle. My grids are kind of all have too many rotations. Okay, so here we had the point 0, 1, so that 90 degrees gave us an asymptote. What about the point 1, 0 or the point negative 1, 0 with respect to y over x? Now y over x, the tangent of 0, y over x, 0 over 1. What's 0 over 1?
0.
0. So at 0 degrees, or 0 radians, the tangent's 0. Okay, pi. At pi radians, or 180 degrees, the tangent is y over x, so it's negative 0 over negative 1, so the tangent of pi is 0 again. 0 radians is the same exact thing as 2 pi. Go backwards. That pi is the same thing as negative pi. Okay? Describe where the tangent graph is 0 with respect to the asymptotes.
The quadrant.
Halfway between. Between two asymptotes, halfway between, we're going to cross the graph. As long as we're not shifted in the next section. Okay? Now, the whole idea of asymptotes is that my graph is contained between them, since we have multiple ones of them. All right, now, this is where you can memorize different things, but I think maybe the easiest thing is to think about the angles. This angle, x, so I'm not going to think about x here as the side of the triangle. I'm going to think about my angles. Between 0 and pi over 2, what quadrant are those angles?
First.
First quadrant, right? What value, positive or negative, is tangent in the first quadrant? Positive. Tangent is positive. So, if the value of tangent is positive, I'm going to be above the x-axis, and the idea is that we're going to approach the asymptote. Okay? Well, let's think the other direction, since I'm confined between these two asymptotes. Now, this is 0 to negative pi over 2. Between 0 and negative pi over 2, I'm now talking about quadrant 4 angles. Okay, be careful. I'm not talking about quadrant 4 of the graph. I'm talking about quadrant 4 of the rotation of the angle. Okay, so quadrant 4, what's tangent, positive or negative?
Positive.
Y over x, y is negative, x is positive, so that makes the ratio negative. Tangent's negative. So we're going to be negative. All right? Between pi over 2 and pi. Between here and here, I'm in quadrant 2. Y is positive, x is negative. The tangent ratio is negative. So between pi over 2 and pi, the ratio is negative. Quadrant 3. Between pi and 3 pi over 2. Those angles in quadrant 3, x is negative, y is negative, the tangent ratio is positive. Between pi and 3 pi over 2 are those angles. And once you say to yourself, oh, hey, look at that, you probably are gonna say the rest of these graphs are just gonna be very similar between the asymptotes. And you would be correct. Okay, so tangent is just gonna repeat like that. What's the period length for tangent?
Undefined.
My period length is pi. Between, from 0 up to pi over 2, from 0 down to negative pi over 2, that total length is pi. So, normal tangent curve is pi. Just the same reasoning that we kind of looked at the reciprocal trig functions, they're the same as sine, so secant, cosecant, they both have a period of 2 pi because they're related reciprocally to sine and cosine. Cotangent also has a period length of pi, okay? There is one point that can be super helpful, okay? If you're gonna have to try to figure out the tangent of some angle in the quadrant, whoops, I wasn't supposed to write that. What angle would you love to figure out the tangent of?
3 pi over 4.
3 pi over 4, why is that?
It was on the test.
Oh, 'cause it was-
Well, just that 3 pi over 4.
45 degrees. What's so great about 45 degrees? 1 over 1, the tangent is 1. Every reference angle of 45 degrees, guess what? The tangent is 1 positive or 1 negative. So, let's just take a look at where is pi over 4, which is 45 degrees. Remember, that's pi over 4. Okay, well, oh, hey, look, right halfway between here. So, although we don't like to think about tangent with amplitude, when there's a coefficient there, we can think of also college algebra graphing techniques. When we have a coefficient there, it vertically stretches it. What we can do to get a better feel for the curviness of tangent is to utilize this halfway unit. Okay, so pi over 4, I'm going to be at 1. And if I go the other direction, I'm going to be at negative 1. Okay, so the halfway point between where it crosses and the asymptote, since that is 1, we're going to be here at 1. And then the other halfway point between where it crosses the axis and the asymptote, we're going to be at 1. So you can utilize those points as well to help you graph a tangent curve. So,
Wendy,
yeah?
how did you find the isotopes again?
Oh, that was looking at this, the tangent, the fact that tangent is y over x. So, here we're not going to think about x being the rotation. Here we're going to think about xy coordinates, okay? And hopefully, you know, you're like, oh yeah, okay, tangent was either 0 or undefined on my quadrantal angles. So, where is y going to have a value and x be 0? Right there. Right there. But I got a better way. Awesome. Your students are awesome. Because, and it's been a while actually. There was a student who said, tangent A, my asymptotes, and that's not the A, about the y-axis. Okay, so your asymptotes. I thought that was genius. So my asymptotes are about the y-axis. Okay, for tangent, you're not going to have an asymptote on the y-axis, but cotangent you will. So the reason why we want to really be careful about the positioning of the asymptotes is because we don't have another graph to figure it out. But this can be a fabulous way to remember without having to go through that thought process. Okay, so let's, how crazy do you want to get?
Not crazy.
Not crazy. Okay, so let's do just a period adjustment. So how about we graph y equals tangent of 1, oh, here, your book is gonna write it, tangent of x over 2. Okay, so we're gonna graph that. What's going on with x over 2? How else can I rewrite that?
1 over 1.5.
1/2 x. Okay, so this half, what does that impact? My period length.
Period.
Okay, so this is going to be related to our period length. Okay, so, oh, it was written somewhere else. How am I going to figure out my period? Just the way we did before, but we're not going to say 2 pi. We're going to say, and if you always keep in mind, normal period length divided by that coefficient. Okay, so now normal for tangent is not 2 pi anymore. Normal for tangent is
Pi.
pi. Okay, so this period is going to be pi divided by 1/2. Okay, and so then we're going to say pi times the reciprocal. This is an equal sign, doesn't look that good. So when we do that, we get 2 pi. All right, now, this is where tangent gets a little bit difficult. Oh! Okay, so, college algebra. When you have a coefficient in with x, it adjusts the width of your graph. Okay, it's either going to expand it or it's going to compress it. This one is expanding it. When it expands it with respect to 0. And when I'm talking with, my 0 mark happens to be the y-axis. So I'm going to expand out in both directions. And what makes this tangent graph a little bit harder, slightly, than cotangent is the fact that my asymptotes are equidistant between or about or around the y-axis. So half the period up, half the period down. Okay? Same exact thing there. I have to have 2 pi on that whole length has to be on either side of the y-axis. So how far up am I going to go and how far down am I going to go?
2 pi.
Well, this whole length has to be 2 pi,
Oh.
which means I'm going to go up to pi and down to the minus pi. And we're going to have an asymptote. And let's just go another, it's going to be right on this silver thing. All right, what happens in tangent graph right smack dab between the two asymptotes?
Reciprocates.
We cross the axis. Right in between the two asymptotes, we cross the axis. Okay? So right in between the two asymptotes, I'm going to cross the axis. This is pi. This actually happens to be 3 pi because it's 2 pi further. So here at 2 pi, we're going to cross the axis. Okay? And then what we want to keep in mind is that this is our tangent graph. Okay? And we rise to the right and fall to the left. Okay? If you want, we can say, if we go back to normal tangent, because you're like pi over 2, and if you use the quadrant angles, then it helps to think about it from 0 to pi over 2 is positive, and from 0 to negative pi over 2 is 4th quadrant, so it goes down like that. That thought process doesn't work so well between looking at 0 and pi, because now you're like, well, that's 2 quadrants, not working, but really it does work because we're taking half of all of them anyway. Okay. We can still use that halfway, that quarter mark, or between where it crosses and the asymptote. The tangent value is going to be 1. So that point right there. So we can go through that point and curve to the asymptote. The halfway mark between where it crosses and the asymptote is going to be this negative. It's going to be 1, but now it's -1. We're going to do that. So we're here, and then whoops, like that. All right, let's graph. Oh, whoops, I graphed it in red, but wrote the equation in blue. Y equals -2 tan. Do you want a coefficient in here?
Yeah.
Just an easy one.
All right, let's make this 3. And let's make this 2x. Okay, so we just did period adjustment, so we're gonna have that going on. This 3 is gonna impact these points here. So we were utilizing the fact that the tangent of 45 is 1, so that's gonna be here, but now it's gonna be, instead of at 1, it's gonna be up at 3. So it's gonna be less curvy, it's gonna be more dramatic. And of course, the negative is gonna wanna do what? Flip it over. So let's kind of write down some pieces of information. Okay, so we know that our tangent curve, our asymptotes are on either side about the y-axis. Okay, we know that a normal tangent is going to do this, but our tangent curve is going to not do that. It's going to reflect it and do this.
Because of the negative.
Because of the negative. We are going to have to be careful in that when I'm here, instead of hitting at 1, we're going to be all the way up here, up at 3, 3 times bigger.
You're not gonna be down 3.
So over here,
Over there, you're gonna be down 3.
we're going to be down right there, because we flipped it. All right, so period. Let's talk about that. What am I going to do to figure out how long the period length is?
Pi over.
Pi,
Normal period
Over
length
2.
over
normal period for tangent is pi. Now I'm going to divide it by that coefficient. So pi over 2. And then what do I have to make sure I remember to do with pi over 2? Equal it about the y-axis. So half is going to be up and half is going to be down. What's half of pi over 2?
Quarter pi.
Pi over 4, fourths, right? So at pi over 4 and at minus pi over 4, whoops, I'm going to have asymptotes. This is going to be super skinny. That is a full pi over 2 unit. Okay, so let's see. Then once you get 1 down, then you can kind of just kind of estimate. So this length, so now I have that. I have another. Then over here. Oh, now that's kind of crazy. Maybe I should have just careful on. I don't like the way this looks. Let's just graph 1 and then we can repeat it after that. Okay. We already talked about how we're going to be going up this way and falling that way. That 3 is going to make, instead of this halfway point, because we crossed through the axis there, this halfway point, instead of being up at 1, we're going to be up at 3. And this halfway point, instead of be down at -1, we're going to be down at -3. So it's going to be a very dramatic and subtle curve. Now we just have to repeat that. So we can sketch in our asymptote, say halfway through between the asymptotes you cross. This this marking, I'm gonna be up here. For that x value, we're gonna be down here. And we're gonna draw, and we're gonna draw.
Probably should have done on tangent first, it's a little easier. Alright, you guys have any questions? Okay. Cotangent. The only thing that's gonna happen, well, you shouldn't say it like that. What's gonna happen? Y equals cotangent x. Cotangent is the reciprocal of tangent. Here, tangent is y over x, so now cotangent is
X over Y.
x over y, which means my asymptotes are going to be in different plot spots. Now my asymptotes are going to be when y is 0, and if we say to ourselves, well, that's going to happen on one of our quadrantal angles, we need 1 over 0. Where does x have a value and y have a 0 amount? Here, and also here, and back. So we're rotating between 0 and pi, and 2 pi, and 3 pi. Okay, so the cotangent of 0 is 0. I mean, undefined, an asymptote. Okay, here, x is -1, y is 0. X being -1, y being 0 is undefined, so pi, I have another asymptote. 0 radians is the same thing as 2 pi. I could go backwards. I could get to pi by going to minus pi. Or have asymptotes. Similar to tangent, halfway between those asymptotes, we're going to cross the axis, because now here, the halfway point angle, so now this is the coordinate 0, 1, and now if I say x over y, now I've got 0 over 1, which is 0. So at pi over 2, we cross the axis. Similarly, the negative part of the y-axis, or at 3 pi over 2, we're going to cross the axis. And similarly, right in between, halfway between the asymptotes is where we're going to cross the axis. So going backwards at negative pi over 2, or here. All right.
So you just shifted the graph, basically.
So cotangent is a shifted tangent graph. Yeah. Almost. Okay. Quadrant 1. Cotangent is positive. Quadrant 1 angles are between 0 and pi over 2. 0 to pi over 2 is quadrant 1. Those angles are going to produce a positive cotangent ratio. And again, that halfway part is going to be at 1.
What do you mean by cotangent ratio?
X over y.
Okay.
Quadrant 2, cotangent is negative. Quadrant 2 angles go from pi over 2 to pi. And again, I forgot I wasn't being particular. I still have that halfway between the asymptote and where I cross. I'm going to be up at 1. Halfway between where I cross and the asymptote, I'm going to be down. Oops. Okay. What do you notice about the curve of cotangent compared to the curve of tangent? It's flipped. So we need to shift our asymptotes and we need to reflect. So where in this section we are not writing tangent curve, or we're not going to talk about that. That's for Wednesday, because we can take a graph and we can write it as a tangent or a cotangent graph. All right. Here. Now, oh, so here the A tangent, the asymptotes are about the y-axis. The O, my asymptote, is on the y-axis. Oh, fabulous. You can thank Katie from about 3 years ago. Can't remember her last name, but I think it was Mom. Okay. So, if we keep that in mind, then we don't have to like do all this x over y and all that kind of stuff. Genius that she is. Because I would always do that. Okay, so, do you want to practice in our cotangent graph, or do we want to have a picture of a graph and then we have to write the equation? Have a picture, write the equation. How fast do you think this thing is going to pull up? Ugh, come on. All right, fine, forget it. Let's not do your homework. We're going to write the equation for. This happens to be number 56 on page 190 if you care and you don't like my drawing. So 56, we're at 1. We are, oh, look at this joyousness. All right, so they drew that, and then drew that. Okay, honestly, I probably on a test, if I was going to ask you this, I would not draw this black curve. Okay, but the black curve is super helpful for us to write the equation. Okay, so if we have to decide between tangent, cotangent, secant, cosecant, which one are you going to pick?
Cosecant.
Secant, cosecant, right? It's definitely not a tangent curve, which means that this black part that I erased is going to be helpful for us to kind of think about, well, which one is it? Is it the one related to sine? Is it the one related to cosine? And now, this definitely tells us the one related to cosine. Which goes with cosine, secant or cosecant? Secant. So we're basically writing y equals secant x, okay? Our coefficient up front technically is not amplitude, but we can think of it that way. Where do our eyes want to look?
Y-axis.
The y-axis here. Okay, so here, +1, here, -1, we had no height adjustment, that's normal. So, you know, we can put a 1 there. Okay, period length. Period length for a regular secant curve should go out to what for normal?
2 pi.
2 pi. Except this one is going to be one of those ones where it's 1. They're like, what? All right, so this is how I think about it. 2 pi divided by the coefficient that I want to figure out has to be 1. So this right here is the period, because it does the complete cycle. It is 1. So when I say 2 pi divided by the coefficient I need, I'm going to get 1. Okay, and if we want, we can simplify this by just calling it C for coefficient. I don't know if the book uses C or if they use B or whatever. All right, I need to solve for this. What could I do?
Multiply by.
multiply both sides by c. So now I get 2 pi c is equal to, oh, wait a minute, that cancels out. Get rid of this, that's not right. 2 pi equals c. So my coefficient is 2 pi. My coefficient goes right in front of the x. So now we're writing y is equal to secant 2 pi x. And it's weird, but it's okay. Just relax, it'll be fine. You can always test yourself or go backwards. Okay, if that's 2 pi divided by that coefficient 2 pi, sure enough is 1, it works. All right. Your test is today till 8 p.m. I recommend if you